In this video, we are going to see formation of partial differential equation by eliminating arbitrary function by method 2. Okay, here the method 2 is nothing but the equation is in the form of phi of u comma v is equal to 0. That is phi is the arbitrary function, u and v are functions of x, y and z. Okay, so here by eliminating this arbitrary function phi, we can able to form a partial differential equation, and that partial differential equation is of the form pp plus qq is equal to r, where this capital P, capital Q and capital R are denoted as given below, where small p small q are the usual notation, that is small p is nothing but dou z by dou x and small q is nothing but dou z by dou y. Okay, so now while eliminating this arbitrary function phi, finally the partial differential equation we are going to get is of the form pp plus qq is equal to r. So that can be obtained simply by substituting in the equation capital P, capital Q and capital R by finding the first order partial derivative of u and v with respect to x, y and z. So now let us move on to an example. Form the partial differential equation by eliminating the arbitrary function for the equation phi of x square plus y square plus z square comma xyz is equal to 0. So here what we are going to take here is u is equal to x square plus y square plus z square and v is equal to x, y and z. Okay, so here we need to find out the first order partial derivatives, that is dou u by dou x, dou u by dou y, dou u by dou z. So here in this method, we have to consider x, y and z all the three variable as independent variable. Whereas in the previous method 1, this z is a dependent variable, x and y are treated as independent variable. Whereas in method 2, we have to consider x, y and z all are independent variable. So since all the three are independent variable, what is dou u by dou x is nothing but 2x, this is 2y and this is 2z. Similarly, dou v by dou x is, since x is of power 1, this becomes 1 and y and z are stated as constant. Similarly, dou v by dou y will be x into z, dou v by dou z will be x into y. Now after finding the first order partial derivatives, we have to substitute in the formula capital P, capital Q and capital R. So we know already that capital P is equal to determinant of dou u by dou y, dou u by dou z, dou v by dou y, dou v by dou z. So this is equal to, already we have found out the derivatives, substitute it. So this will be 2y, 2z and xz and then xy. So this is equal to, so here P is equal to the formulas determinant of dou u by dou y, dou u by dou z, dou v by dou y, dou v by dou z, which is equal to determinant of, we have to substitute the corresponding derivative here. So 2y, 2z and then xz and then xy. So again you have to expand the determinant. While expanding the determinant, this gives you 2 into xy square minus 2 into xz square. Similarly, we have to find out for capital Q. So capital Q is equal to dou u by dou z, dou u by dou x. Here dou v by dou z, dou v by dou x. So this is equal to, now we have to substitute the corresponding term here, so that this gives you 2z, 2x and then here xy and then yz, which is equal to, expanding this determinant, 2yz square minus 2yx square. Similarly, R, capital R is dou u by dou x, dou u by dou y, Similarly, dou v by dou x and then dou v by dou y, which is equal to, again here this becomes 2x, 2y, y is it, x is it. So expanding this determinant, 2x square z minus 2y square z. Okay, so here in this term we can take 2x as a common term, so y square minus z square. This is equal to 2y as a common term, so z square minus x square. Here 2z as a common term into x square minus y square. Now this is capital P, capital Q and capital R. So finally what will be the corresponding partial differential equation by eliminating the arbitrary function phi is, we know that PP plus QQ is equal to R. So this can be written here as capital P is 2x into y square minus z square into small p plus 2y into z square minus x square into small q, which is equal to 2z into x square minus y square, that is r. So throughout we are having 2 common, we can cancel it. So finally what is the partial differential equation is x into y square minus z square into small p plus y into z square minus x square into small q is equal to z into x square minus y square. So this is a partial differential equation we have obtained by eliminating the arbitrary function phi in this equation. So here we have eliminated the arbitrary function phi here. So the resultant equation what we have obtained here is the first order partial differential equation. Let us move to the second example. The question is, form the partial differential equation by eliminating the arbitrary function for the equation phi of z square minus xy comma x divided by z equal to 0. So here it is of the form phi of u comma v is equal to 0. So that let us take u is equal to z square minus xy and v is equal to x divided by z. So now as usual let us find out dou u by dou x, so which is equal to minus y, dou u by dou y is equal to minus x, and then dou u by dou z is equal to 2z, and then similarly here dou v by dou x is 1 by z. Dou v by dou y will be 0 because there is no term involving y. So totally it is considered as constant. So this becomes 0. Next is dou v by dou z is equal to 1 by z. Differentiation of 1 by z is minus 1 by z square, and then x is treated as constant. So differentiation will be minus x by z square. So now these are the partial derivatives. This we have to substitute in capital P, capital Q and capital R. So already we know that capital P is equal to determinant of dou u by dou y, dou u by dou z. Similarly, dou v by dou y, dou v by dou z, which is equal to, now let us substitute what is dou u by dou y, which is equal to minus x, and then dou u by dou z is 2z. Again dou v by dou y is 0, dou v by dou z is minus x by z square. So this is equal to, expanding it, this gives you x square divided by z square, because minus x into minus x by z square is x square divided by minus into minus plus, so x square divided by z square minus 0 into 2z gives you 0. So this is equal to x square by z square. Next is we have to find out capital Q. Capital Q is dou u by dou z, dou u by dou x, and then dou v by dou z, dou v by dou x, which is equal to, now we have to substitute the derivatives. So this is 2z, this is minus y, and this is minus x divided by z square, and then 1 by z. So this is equal to, now you expand the determinant. So this becomes 2 minus, because 2z into 1 by z gives you 2, minus of xy divided by z square, and capital R. Capital R is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So this is equal to, substituting the derivative, this is minus y minus x, 1 by z, and then 0. So this is equal to, multiplying it, this gives you 0, minus of this is minus of minus plus, so x divided by z. So the answer is x divided by z. Now put it in the equation, capital P into small p plus capital Q into small q is equal to R. So this gives you x square by z square into small p plus 2 minus xy by z square into small q is equal to x by z is R. So here throughout the denominator, z square is common in the left hand side, z is common in the right hand side. So in the left hand side, let us take z square as LCM. So this gives you as the answer x square p plus 2z square minus xy into q is equal to xz. So this is the corresponding partial differential equation we have obtained by eliminating the arbitrary function phi. Okay, and moreover this is the first order partial differential equation we have obtained, because here we have to eliminate only one arbitrary function phi. So thank you for watching this video.